Hey pre-calculus students, welcome to a great school year. This year we're going to start off our pre-calculus studies with the introduction of trigonometry. Trigonometry is the study of angles. So we're on page 3 in our notes packet, and let's just jump right on in and dig in. So we're going to jump right on in here. So we're going to label the following. So this is the initial ray. This right here, this funny letter, that's the Greek letter. We call it theta. You use it in geometry. We use theta to represent angles, just like we use X to talk about side-to-side movement and Y to talk about up and down movement. In math, we have universally accepted this Greek letter theta to represent angles. And then this over here is the terminal ray. So what happens is, I'm going to start at my initial ray, and in standard position, which it talks about right down here, my standard position is along the positive x-axis, so if this were a coordinate plane like that, and I'm going to rotate up or counterclockwise to a terminal ray, forming some angle theta. So it says in standard position, the initial side or the initial ray is along the positive x-axis. We can have positive angles and we have negative angles. And for me, the easiest way to remember this is when you go up, it's positive. When you go down, it's negative. So if I'm in my standard position right here and I rotate up this way, then my theta would be positive. But if I go down this way, then my theta would be negative. I'm gonna write that underneath. So for positive, you go up, which we're gonna call, hang on, I'm gonna erase that real quick and make it a little bit clearer. Oops. So we would go up or counterclockwise for our positive ones. And for our negative angles, we would go down or clockwise. Angles that have the same initial ray and same terminal ray are known as coterminal. They start and stop in the same place, but the way they got there may not be the same. So for example, so it might be that, I'll draw a coordinate plane really quick. I might have a little coordinate plane, and let's say I'm going to start right here, and I might rotate up this way and end here. So there's my one angle. Well, I also could have started right here and gone down this way and made a theta. Those two red and yellow thetas are coterminal because they start and stop in the same place, but they just went in different directions. Okay. So before I tell you what a radian is or try to explain it to you, most of you are at the age where you're learning to drive cars or driven something, possibly. And when you are driving in the United States, we use miles per hour. And everywhere else in the world uses the metric system, and they drive in kilometers per hour. Angles can be measured in lots of different things. When you were in geometry, your angles were measured in degrees. And now that we're in pre-cal, we're going to measure them in a different unit called a radian. So what exactly is a radian? So a radian is the measure of a central angle. So measure of a central angle. And that measure intercepts an arc S equal to the radius of the circle. This right here is my magic formula. My theta is equal to S, some arc length, divided by the radius. So let's think about this for a second. Let's talk about a circle. Let's see how many radians there are in one circle. So if I want to find out how many theta radians there are in one circle, we first need to talk about the arc length of a circle. Well, the arc length of a circle is also known as it's also known as the circumference. And the circumference of a circle we know is measured as 2 pi r. And then we're going to divide out the radius. So divide by r. You'll learn this year my favorite game, Miss Guidry's favorite game, is called Slashy Washy because these r's are going to cancel out. So those r's cancel out. And so in one circle, the theta, or in radians, is going to equal 2 pi radians. So how many radians are there in one circle? There are 2 pi of them. Okay, down here at the bottom, complementary and supplementary angles. Complementary angles are two angles that add up to form 90 degrees. And supplementary angles are angles that add up to form 180 degrees. I have a little trick to remember this, or a couple little tricks actually. So my first trick is that if you draw a C for complementary and an S for supplementary, and then you draw a line through them, the 9 came from the C, so the C has to equal the 90. And when you draw a line through this one, the S became an 8, so it had to become a 180. Another way to think about it is if you, this is like the math person in me, if we know that complementary, or we let C equal 90, and S is like doing one C and then another C, so it's like a 90 plus a 90, so that makes it 180. See, not so bad so far, just some vocab. Okay, so we're going to go to the bottom of page 3. We're going to talk about coterminal, and we're going to talk about it again later in this chapter, but let's introduce it now, and we're going to keep talking about it over and over and over again. Okay, again, so coterminal is a new vocab word. Coterminal means that we have two angles. They started in the same place. They ended in the same place. Co means together. Terminal means to terminate or to end. So they're going to start and end in the same place, but they just go in different directions. Think about it like you were coming to George Ranch and going to your math class. Some of you might decide when you walk in the front doors of George Ranch to go up the stairs that are right there kind of outside Miss Gann's room by what was the student service window, and then walk to your math room. And some of you might decide, no, hey, I'm going to stay on Main Street, and I'm going to go down Main Street and then go up the stairs over by the math hallways and then go to your math classroom. Either way, you started at the front doors of the school and you went to your math classroom, but you went different directions. So it says find an angle such that 0 is less than theta, is less than 360, that is coterminal to each of the following. So let's draw first what number 1 looks like. So number 1, I'm going to do in yellow, 400 degrees. So this is going to be in standard position. So we're going to start again on our positive axis, and we're going to rotate 400 degrees. Every quadrant is 90. So 90, 180, 270, 360. If this is 360, then I have to go 40 degrees more. So this little piece right here is 40 degrees. You can see you drew a whole circle and then some. So to find something that's coterminal, that lies in between this right here, it means you want to take away the extra circles because I only want to be one circle between 0 and 360. So what you're doing is saying that I need to take away the circle that I drew. So I'm really going to do 400 minus that 360, that extra circle that I had, which makes that 40 degrees. And that's the answer for number 1. Let's try number 2. Well, number 2 we'll do in green. Go way down here. I'm going to draw it. This one, be careful, it's negative. So that means instead of going up and go counterclockwise, we're going to go down and go clockwise. So I'm going to start right here on my positive x-axis. This is negative 90. And then another negative 90, which makes 180. And then another negative 90. So now I'm at negative 270. I need to go just a little bit more. So this piece right here is my 10. So that's what I have. I don't want to have a negative angle according to my restriction. So something coterminal that would be positive would start right here and it would go up to that piece. Well, every quadrant is 90, and if I have 10 right here, then 10 less 90, so my 90 minus my 10 makes this piece right here 80. It's not always going to be that you add or subtract a certain number. It's a little bit of a logical thought process. You're finding, in this case, you're finding the little piece that's between 0 and 360, and you're getting to the same terminal ray right here. Let's try the next one. I'm going to do it in blue. So we're going to do big number, 940. So let's see. Let's try this one. Actually, pause the video for a second, and you try it. Okay, so here we go. It's positive, so I'm going to go up. So I'm going to start here. 90, 180, 270, 360. If I go another 90. Oops, sorry. I'm going to be at 450. 450 plus another 90 is going to be 540. 540 plus another 90 is going to be 630. 630 plus another 90 is going to be 720. And we should have known that. Two circles. One circle is 360 degrees times 2, 720. I'm going to add another 90. That should make me be at 810. And then another 90 puts me at 900. So that means I don't need to go the whole next one. I only need to go 40 degrees more. This little piece right here is 40 degrees. My answer is not 40, though. Remember, I have to be between 0 and 360. So I'm going to use a little bit of red to help me out. I'm going to start here, and I want to get to here. I have to go up this way so it stays positive. So 90, 180, and then this little piece right here was my 40. So 180 plus my 40 makes this 220 degrees. So 220 degrees. And then the last one we'll do in white. So number 4 says coterminal. So negative 630. So start here and go down because it says negative. So here's a negative 90, negative 180, negative 270, negative 360, negative 450, negative 540, if I went all the way here, it'd be negative 630. I don't want to go all the way here because I'm only at my 624. So I'm going to stop just short. And this little piece in here is the just short piece. 630 is 6 short, or 6 more than the 624 that we had. So I'm going to use a red again to help me. So I want to start here, and I want to end here, and I have to go up in this positive direction. So 90 plus this little piece that was 6. So my coterminal answer is 96. Halfway there, and the next page is even easier. We got this. Okay, we're going to talk a little bit about conversions today, and it's going to come up later this week again, and next week. So we're going to figure out how many radians and degrees there are in relation to each other so we can convert back and forth. So I think most of you have probably taken chemistry, and you use what they call the railroad tracks to do conversions. So I'm going to make a little railroad track. It's really just a fraction, though. So let's talk about a whole circle because we know a lot about circles. So if I'm in radians and I want to get to degrees, the thing you want to get to is where you want to end up. So the thing that you want to get to always goes on top. So there's 360 degrees in a circle. And if you remember from a couple of slides ago, we proved that in one circle we did the little theta equals 2 pi r divided by r. And so we proved that there was 2 pi radians in one circle. So if I have 360 degrees, that's the same thing as saying 2 pi radians. Some people put the little r there for radians, but you don't have to. When you don't label an angle in math, we assume radians. And I'm going to write that down. That's so important. Little thought bubbles. I like to have thought bubbles. When you do not, big capital not, label an angle, it is assumed to be a radian. Great. Okay. So let's cancel some stuff out. So my 360 and my 2, these can reduce. And so I'm going to get 360 divided by 2 is 180 degrees over a pi. So that's my conversion if I want to go from radians to degrees. And if I'm going from degrees to radians, you can flip the fractions over and do pi over 180. My little tip is, again, whatever you're going to, the 2 is what goes on top. So I'm going to radians, so that's what went on top. Revolutions, if you don't know what a revolution is, RPMs, it's how many times a circle goes around. RPMs is how many times your tires go around per minute. Revolutions is how many times do I revolve around the whole circle. So if I have, this says if I have 1/6 of a revolution, how far around the circle have I gone in degrees? So revolutions, I always think a fraction or the part of what whole. So I have 1/6, and then to go to degrees, I have 1/6 of 360 degrees, because the whole circle is 360. This is like 360 over 1, so the 360 divided by 6 makes 60 degrees. Same idea, radians, I have 1/6 of a revolution, a whole circle. Again, we're using this right here that we know that there's 2 pi radians in a circle. So now I'm going to have 2 pi over 6, which means there's pi over 3 radians in a circle. Not so bad. Okay, last 2 little things we need to talk about. Arc length and area of a sector of a circle. So arc length first. It says for a circle of radius r, the central angle theta that intercepted by an arc is given by the formula. This formula written here should be very familiar because on the earlier we said that theta, oh, that's horrible. Let's pick a different color. Hang on. Different color. Earlier we said that theta equals my arc length over my radius. So all they've done in this is multiplied both sides by an r. And so now we have that theta r equals s, which is the same thing I circled in yellow. So same formula, another formula that you have to memorize. Same one, just a different way of writing it. The very important part, though, that we're going to get stuck on is this. Theta must be in radians. This is what kids always mess up. They forget to make sure that theta is in radians. So let's do this problem. Sorry, guys. So it says that my circle has a radius of, I like to underline important stuff, a radius of 4 inches. Find the arc intercepted by the central angle. Here's my central angle. So I'm trying to find the arc. I'm trying to find the S. So if S equals r theta, and then remember, it must be in radians, S is going to equal, my radius is 4 inches. I cannot plug it in, though, because this is in degrees. So we're going to use what we just learned on the last page. 240 degrees times, I need to convert to radians. I want to go 2 radians. The 2 thing goes on the top. So I'm going to put my pi on top over my 180 degrees. Again, my favorite game is called Slashy Washy. Things cancel out across this railroad track because my degrees cancel out. And then my zeros will cancel out too. So now I'm left with 24 over 18. Old school math. Don't grab a calculator. Let's use our brains. Let's see. What numbers go into 24 and 18? Maybe a 3. So how about 8? Nope, 3 doesn't go into 18. See, even my math skills are struggling a little bit. How about we do 2, 12, and 9? Oh, a 3 would have worked. I'm so silly. Of course, I should trust myself. So 3 goes in there, 4 and 3. And don't forget about your pi. So this converts to 4 pi over 3. And since we're not using a calculator, we're going to multiply in our brain and just leave the pi in there. You can do it. This is like a 4 over 1. So 4 times my 4 is going to make a 16 pi over 3. Story problems have story answers. It will be a broken record this year if I don't say this over and over again. I would be failing as a teacher. It is that we are finding an arc length. An arc length is a distance. The distance in this problem was measured in inches. So, inches. Story problems, story answers. You got to label, kiddos. Okay, let's do this bottom one. The area of a sector of a circle, the area, I don't like it how it's typed, I'm going to rewrite it. Area equals 1/2 r squared theta, and again, can't mess this up, guys. Theta must be in radians, so let's make sure it is. So I'm going to make a pie, and the pie is going to have a diameter of 10 inches that I'm going to share with my mom and my dad, and they want to know what is the area of each piece, if each person's piece is equal, and we're going to consume the whole pie. So I cannot draw. You'll learn this quickly this year. So here's my grate. It's a horrible circle. Let's try one more time. It's times like this that I miss my smartboard the most because I could insert the circle. I probably could do, look, I'm just going to be smarter. Let's see if I can do this. Oh, look at that. I found an insert tool. So here's my beautiful circle for my pie. It's got a little crust on it. I like to bake. So I'm going to be making an apple pie. But I'm going to split this into 3 pieces, 3 equal pieces. So 1 piece, 2 pieces. So there's my 3 equal pieces. It says that my diameter is 10 inches. Well, those lines I drew are not diameters. They're radii. So each one of them is 5 inches. And the whole circle is worth 360. So I have 360 degrees. But I've split it over 3 pieces. So that's equal to 120. We also could have, and probably should have done it the other way. We can convert this to radians, because remember, it has to be in radians. Or we could have said the whole circle in radians is 2 pi, and I'm dividing that into 3, so this is my theta in radians. Let's convert this really quick just to prove it's the same. Multiply by a pi over 180, because we're going 2 radians. 18 over 12, 18 pi over 12 is going to reduce to, let's do 3, so 4 pi over 6, and then it's going to be 2 pi over 3 when you reduce one more time. Should have done 6 into both of them. That would have been better. But so this right here is my theta. So now I can use my formula. So my area is going to be equal to 1/2. My radius is 5 squared. And then my central angle was 2 pi over 3. I'm going to cross this off. This is really a 25. And when you combine this piece with this piece, you get 25 over 2. So right now I have 25 over 2 times my 2 pi over 3. These 2's cancel out. So my final answer is going to be 25 pi over 3. Story problems have story answers. It's an area. This pi was measured in inches, so it's going to be inches squared. So make sure you have these notes done for tomorrow. You will have a chance in class tomorrow to ask questions about it, but if you don't have them filled out, then you won't have any questions, and then you'll be defeating the learning process.